Now I'm going to answer the question regarding the presentation. First of all, what is the problem addressed in this paper? And the problem is to achieve a more efficient data center computing. And is this an important problem? Yes, because data center can consume 30% of the total electricity in 2060, and this consumption will double every 4 years. Did the author motivate convincingly this problem? Yes, the author tried to achieve lower energy per request, which reduce overall data center energy consumption. And the importance is practical. So are there any solution out there for this problem? Yes, FPGAs and GPU-net. So what's wrong with this solution and why only sufficient? And the first one is FPGA, and it is not sufficient. It's because it has long reconfiguration time and it is not flexible. And the second one is GPU-net. The GPU-net targets on InfiniBand hardware and traditional application. And data center targets on commodity hardware and non-traditional applications. So the similarities and difference between this work and existing solution. GNAND is similar to GPU-net, that it aims to improve the support for application requiring network I/O on GPU accelerators. The novel contribution proposed in this paper is GNAND software and memory cache GPU. Is this a significant contribution? Yes, because it maintains high throughput and low latency while using relatively low energy per request. And it is incremental because the paper is based on author's previous work. How did the author demonstrate that their solution works? So first of all is the theoretical analysis. For example, GPU Direct, which bypass GPU and sends the RX packets directly to GPU memory. Then prototype implementation, for example, GNOME software and memory cached GPU. And then the simulations on a single memory cache server and client directly connected using two Ethernet cables. After that, the author compares the GNOME and memory cache GPU's results with the control group. Did they demonstrate this many times or just one or two? From the example of evaluating the throughput, we can see that the author averaging the output over 3 runs so that the data are more reliable. Did the author achieve what they set out to do? Yes. Using GNOME and memory cache GPU is able to achieve 10 gigabit line rate processing at all request size and using only 16.1 mJ of energy per request while maintaining 1.1 millisecond low latency on high performance NVIDIA Tesla GPU. Is the paper well organized and presented? Yes. The author first point out the problem of data center energy efficiency, then introduce some background knowledge regarding this paper, and then introduce the GNOME software architecture and the design of memory cache GPU. The paper then evaluates the proposed solution and compare with the relating works, and finally present the conclusion of potential to exploit the efficient parallelism of GPUs for network-oriented data center service. What did we learn from this paper? The first one is details make a difference. In memory cache the GPU, we talk about set request ordering is very important. And if the author did not think thoroughly before the implementation, it will cause some problem. For example, if the set request first update the GPU hash table, then allocate the item data in the CPU memory. Under this scenario, set request immediately followed by get request will cause error. And the second point that we have learned from this paper is that we need specific solution for specific problem. We have mentioned that the author modified the baseline memory cache implementation. Although the traditional baseline can resolve the problem of collision, however, the design is a poor fit for GPU architecture. So we cannot just copy others' successful solution without examine the detailed implementation of the design, because it might contradict with what we are going to achieve. In this paper, the traditional implementation of memory cache can degrade efficiency, and it is in contradiction with what we are going to achieve. So much for the presentation, and thank you all for your listening.